In this video, we are going to just go over some additional examples for solving triangles using trig ratios. Notice we are going to use the same triangles from the previous examples, so it may be best for you to get a new sheet of paper and redraw those triangles so we can relabel them and mark them for the new side that we're going to find. Notice for this example, we're going to find ST where previously we solved for SU. So we are going to relabel and remark the triangles based on what we need to find. So example 7, we're going to use triangle STU, but this time we're going to find side ST. So here S to T is our side that we're going to solve for, and notice what we are given. We're given our theta angle and the 87. So let's label those parts. The theta angle is that 54 degrees. The 87 is opposite that theta angle. And the piece now that we're trying to find is our hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle. So based on what you're given and what you need to find, let's decide on our ratio. Some old hippie, where old hippie is exactly what we have, so that's going to be sine. So sine of theta is opposite over hypotenuse. So let's plug in our numbers. Sine of 54, that's our theta angle, equals opposite is 87 over hypotenuse is what we're trying to find. So we're going to solve this by multiplying by x on both sides. Because they divided by x, that's how they will cancel. Multiplication and division are opposite operations. Although notice that doesn't get x by itself. We'll have to take another step to actually solve and get x by itself. So that means we're going to need to divide by sine of 54. And now that gets x by itself. So we're ready to punch this into our calculator. Always remember to check your mode. We are still in degrees mode, but if you've used a different calculator or another student might have used your calculator, always check that mode. So we have 87 divided by sine of 54. That's going to come out, we're rounding to the nearest tenths again, so that's going to come out with 107.5. That 3 will not make this round up. It doesn't matter anything behind that. We only want to look behind the tenths place. If we're rounding the nearest tenths place, look behind to see if it makes it round up or stay the same. So we have x equals 107.5 because that 3 will not make it round up. It makes it stay the same. Let's look at our next example. Here we're asked to find the measure of MN. So M to N. And we are given the 19 and the 42. So of course the 19 degrees is going to be our theta angle, and from that angle we're going to label the other parts. The piece that we need to find is our adjacent side, and the other piece, 42, that was given to us is our hypotenuse because it is opposite that 90 degrees. Notice the opposite side from that angle. We don't know that piece, we don't need to know that piece, so I don't recommend labeling it. So let's decide on our trig ratio. Some old hippie, well, we don't need or have that opposite side, so old hippie won't work. Caught another hippie, so another hippie, that is cosine. So cosine of theta is adjacent over hypotenuse. Some old hippie caught another hippie, so caught another hippie. So cosine of our angle of 19 equals, the adjacent is the piece we need to find, over hypotenuse we know. So we're going to use this to solve for x. They divided by 42, so we're going to multiply by 42. When you multiply by 42, that gets your x by itself. So you're ready to go and punch this in the calculator. We have to get x by itself before we can ever type anything into our calculator. So we have 42 cosine of 19. Rounding that to the nearest tenths place, the 1 that's behind that will not make this round up. So 39.7. let's look at example number 9. We're trying to find this time for xz. So xz is here. Our pieces that are given are 47 degrees and the 26. So from that information, we're able to find what ratio we'll use. So our theta angle is 47 degrees. We're needing to find the opposite side, and we were given the adjacent side. So we can exclude some old hippie caught another hippie because both of those cases would need the hypotenuse. So we know that we're going to use tangent based on what we were given. Tangent is opposite over adjacent, and those are the pieces we have or need to find, which is why we picked tangent. So tangent of 47 equals opposite, we don't know, so use a variable. Adjacent is 26, and now we'll solve this. Do so by multiplying by 26 on both sides, and that gets x by itself. Multiplication and division are opposite operations, so it gets x by itself. It isolates that variable. So we're ready to type into the calculator. 26 tangent of 47. So we have 27.8. Behind that is another 8. Because that is a 5 or more, it's going to make this round up to a 9. So 27.9 for this side length. Let's take for a moment and look at our previous examples that we solved using these same triangles. So notice previously we found side SU, and that was 63.2. Now we find here this was side ST for 107.5. So now that we have all three sides, we could actually check this with the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. It does not matter your a and b, just let one be a and one be b, as long as you pick the sides of that triangle. So we're going to let 87 be our a. We solved for the other leg in the previous example, so 63.2. And that should equal the hypotenuse that we found. So 107.5 squared. So of course, once you set that up in the Pythagorean theorem, we can use our calculator to help us check. So 87 squared plus 63.2 squared, all of that equals this value. So 107.5 squared. Notice, oh, they're quite off. They are close, but because of the rounding, they are, did I write something down wrong? They are close enough to say that they are probably solved correctly. I think I also took, let's see, if I take the square root of this, it worked out even better to be 107.5, but because of that rounding, it's going to be a little bit off from our check, but we're close enough. I mean, I know it's quite a bit off, it seems, but it is quite close enough in order to say it does check out. So it is a cool way to check, although it doesn't come out exact because of rounding. You could do that in the other examples also. The closer you are to having exact answers, the better it will come out in a check. So I know that first check didn't go great. It kind of threw me off when they weren't exact. But I guess because I checked it by taking the square root originally, it does work out a little bit nicer. So let's continue with our additional examples. Here, example number 10, we're going to solve for angle C. So notice this time we have here angle C. So that is our theta angle. The pieces that we are given, this 5 and the 10, The 5 is the adjacent to the theta angle, and the 10 is the hypotenuse. Remember, the hypotenuse is always opposite the 90 degree. So based on that adjacent and hypotenuse, we find our trig ratio. Again, remembering to find an angle measurement, you're going to use the inverse trig ratios. Adjacent and hypotenuse is cosine, so angle theta is going to be inverse cosine of adjacent over hypotenuse. So angle C this time is inverse cosine. Our adjacent is 5. Our hypotenuse is 10. So because what we're trying to find is already by itself, we're ready to type this into our calculator. So inverse cosine of 5 over 10 gives us 60. Remember, these are angle measures in degrees, so it's 60 degrees. So this one especially checks out nicely with our previous example. If you'll remember, we've previously solved for angle A, that was 30 degrees. Angle C is 60 degrees, and of course we already know angle B because these have to be right triangles in order to use the trig ratios. So 30 plus 60 plus 90 gives us 180 degrees. The sum of the angles of a triangle should always equal 180 degrees. So 30 plus 60 plus 90, the sum of all the angles. This one does definitely check out nicely and actually is exact because there was no rounding involved. So let's keep looking at our examples. Measure of angle K, so we're trying to find here. We know that 93 and 46 are given to us. So angle K is our theta angle. The 93 is opposite, and the 46 is adjacent. The hypotenuse is not given to us, and we don't need to find it, so I do not advise that we label that piece. So some old hippie, again, we don't have the hypotenuse, caught another hippie, still don't have the hypotenuse, so we can exclude sine and cosine. So this would mean that inverse tangent is what we need to use. Opposite over adjacent. Again, remembering because we find an angle measurement, we're going to use an inverse. So angle K is going to equal the inverse tangent of our opposite side, which was the 93, our adjacent side, which is the 46. So because our variable, what we're trying to solve for, is by itself, we're ready to type this in the calculator. So we have inverse tangent, so second tangent of 93 over 46. Rounding that to the nearest whole degree, look behind, this 6 is going to make this round up to 64 degrees. Again, you can check this with the previous example we did. We previously found angle J to be 26 degrees. Angle K is 64 degrees. And of course, we know angle L is 90 degrees. So 90 plus 64 plus 26 gives us 180 degrees. The sum of all angles of a triangle should be 180 degrees, no matter what type of triangle. Of course, we're working with right triangles, but all triangles, the sum of their angles is 180 degrees. Let's look at our final example now. We have the measure of angle J is what we're asked to find, or measure of angle Z is what we're asked to find. So there's Z. We're given the 16 and the 20. So our theta angle is what we're trying to find. We're given the measurement of our opposite side and our hypotenuse. Again, remembering our hypotenuse is always opposite our 90-degree angle. So some old hippie, that's exactly what we have. So that's inverse sine, of course, because we're trying to find an angle. Inverse sine is opposite over hypotenuse. So our angle is angle Z. Inverse sine, opposite is the 16 over hypotenuse is 20. So because our variable, or what we're trying to find, is by itself, we're ready to go to the calculator. We have inverse sine of 16 over 20. We find that that's 53 degrees, rounding nearest whole number. This 1 will not make it round up. It stays the same at 53 degrees. So angle Z is 53 degrees. Again, we can check that. 53 plus 90 plus what we previously found for angle Y was 37 degrees. So 53 plus 90 plus the 37 degrees checks out to be 180 degrees.